This is the final video for Chapter 6, and in it I'm going to be discussing periodic trends. There are several very important properties of elements that will be used quite a bit moving forward, and they all follow specific trends along the periodic table. So first I'm going to go through and define them, and then I'm going to show you what the trends are for each. So the first one I want to talk about is ionization energy. So I've talked about ionization already. Ionization is about pulling off an electron to make a positive ion. Because remember, when you lose an electron, you become positively charged. So the ionization energy is the amount of energy required to pull off the outermost electron, which again, remember, is called the valence electron. So low ionization energies belong to elements that are more easily able to lose their outermost ion. So what are the elements that like to form positive ions? Well, we know group 1 always form positive ions, so they can very easily lose their outermost electron. So they have a very low ionization energy. However, if we go all the way to here, nonmetals like to be negatively charged, which means they really, really strongly do not want to lose electrons. They actually want to gain electrons. So the amount of energy that would be required to forcibly pull off the outermost electron would be very, very high. So the ionization energy increases going left to right across the periodic table. Also, at the top, the outermost electron, and this actually deals with the next trend that I'll talk about, but the outermost electron is much, much closer to the nucleus at the top one than they are for the elements at the bottom. And if it's closer to the nucleus, there's a stronger attraction between the two, and so it requires much more energy to pull off the outermost electron for elements that are high on the periodic table. So as you go down a group, the ionization energy decreases. So I'm going to say it increases going left to right, and it increases going bottom to top. Okay, the next one I want to talk about is the atomic radius. So the atomic radius is just talking about the size of the elements, how big they are. Now, the one that's pretty intuitive, as I just mentioned, is as you go down, so if we remember back to the quantum numbers, as you go down a group, every time you add a whole extra shell, a whole extra energy level. So that's going to make it much, much larger as you go down a group. So the atomic radius increases going down. The trend that's a little less intuitive is going left to right. So going left to right, I feel like a lot of people would expect it to get bigger, but actually the atomic radius decreases as you go left to right across a period. So basically the reason why is because as you go across a period, you're not changing energy levels at all. So the electrons are still basically stuck in the same outermost energy level, but as you go, each time you go up an atomic number, that means you add a proton to the nucleus. So you get a stronger and stronger positive charge in the nucleus every time you add a proton, and that positively charged nucleus in the center is pulling on electrons that are stuck at the same energy level away. And so the increase in positive charge in the nucleus is able to pull them in tighter, so the radius actually decreases going left to right. So again, atomic radius, size of the atom, and it increases going right to left, and also increases going top to bottom. Okay. Next, I want to talk about electron affinity. So the electron affinity is effectively the exact opposite of ionization energy. So the ionization energy is the amount of energy required to pull off the outermost electron to form a positive ion. The electron affinity is a measure of that element's likelihood to accept an electron to form a negative ion. So of course, looking at a periodic table, we know that the nonmetals like to form negative ions, whereas the metals very much do not. So it makes sense that these would have a higher electron affinity. Now, one thing to keep in mind, so the actual values for electron affinity, you won't have to worry about calculating them or anything. And actually, the stronger electron affinity, the more negative it is. So if you have much more negative electron affinities, it looks like that's smaller, but that's actually a more favorable electron affinity. So as you go left to right across a group, you go from metals, which do absolutely do not like to accept electrons, to nonmetals, which very much do. So the electron affinity, again, it's the element's likelihood to accept an electron. And again, so it's going to increase, going left to right across a group, across a period. And then the vertical trend is not as defined for electron affinity as it is for the other two, and for the next one I'm going to talk about. So there are definitely a lot of exceptions for the vertical trend, but not for the horizontal trend. But for the vertical trend going up and down, there are some exceptions, but generally speaking, the electron affinity is going to increase when you go bottom to top. So as you go up a group, generally speaking, the electron affinity increases. And the reason why is because as they get smaller when you go up, basically just the fact that it's closer to the nucleus makes it that significantly closer to the nucleus makes it that much more able to use that positive charge in the nucleus to attract electrons from other elements and become negatively charged. All right, and the last trend I'm going to talk about here is called metallic character. Oops. So metallic character basically just means its likelihood to behave like a metal. A metal. And so metallic character, if you think about it, basically, is so that basically means it's likelihood to give off electrons, because that's what metals like to do. They like to give off electrons, right? So the metallic character is going to be basically the exact opposite as ionization energy. It has to be, because remember, ionization energy told you how much energy it took for something to give off an electron. Another way of wording that is saying it's the amount of energy it takes to behave like a metal, right? And again, the lower the energy, the easier it is for that to happen. So a low ionization energy means it's an element that is very readily able to behave like a metal and give off its electron. So that means that, and of course, looking at a periodic table, as you go from right to left, from the nonmetals to the metals, hopefully it makes sense that the metallic character would increase going right to left. And then again, since ionization energy increases going up vertically, as you go down, that's going to decrease, or I'm sorry, that's going to increase the metallic character. And effectively the reason why, just like all the vertical trends, it has to do with size. As you go down, you get larger and larger, so the outermost electrons become further and further away from the nucleus, and the further they are from the nucleus, the easier it is to give them off. So those are the 4 trends. Now I'm basically just going to make a model. So as you can see down here at the bottom of the page, I drew from scratch a little outline of a periodic table. And so I'm just going to basically show the general trends. So for ionization energy, so in this way you have basically a single picture that shows all of them. So ionization energy, I'm going to have it orange. And again, I said that ionization energy increases going to the right and up. So I'm basically just going to draw an arrow like that. So it increases going to the right and up. And one thing I do want to note is that all of these trends completely disregard noble gases. Because remember, noble gases do not like to react at all. So for all of these trends, you can just say, well, except for the atomic size. Atomic size does include noble gases. But other than that, the other 3 do not. Okay, so next I'm going to use blue for atomic radius. And again, I said that atomic radius increases going to the left and down. So now I'm basically going to draw an arrow opposite the ionization energy in blue. So the atomic radius increases going down and to the left. Alright, I'm going to use green for electron affinity. And if you recall, electron affinity increases going to the right and up, somewhat going up. Again, it's not as solid as the other ones, but that is the general trend. So that arrow is going to be the same as the ionization energy one, increasing going to the right and up. And our last one, I'm going to do metallic character in pink. And remember, metallic character increases to the left and down, just like atomic radius. So that arrow is going to look just like the blue atomic radius arrow.